Okay, this is a Daihatsu Rocky or Daihatsu Fourtrak, depending on what you want to call it. There's also F numbers that they give the four-wheel drive car from the 1980s through to the 90s and so on. But this is off a 2.8 diesel Daihatsu Fourtrak or Rocky. This is the starter motor, I should say, first of all. And if you're ever looking at it, you'll be looking at it from this angle down through your engine bay. Oh, the sun's blocking the view. Right, from a sort of this angle, looking down on it at the side of the engine on the left hand side when you stood at the front of the car. Now, as I say, it's a 2.8. Now these are prone apparently to solenoid failure. Basically you turn the key and all you get is a clunk. The starter motor won't spin over. Now this is a little bit different to other starter motors I've seen in the past. Normally on the sort of starter motor where you have a solenoid to engage the cog on the starter, you normally have the starter motor part, the actual motor that spins, in line with the gear. In terms of this part, which happens to be the motor, is normally over here, and the solenoid, which on this one is mounted over here, is normally on the side. So this is a complete switch around. So it quite surprised me, and I was looking at it and going, I don't really fancy trying to strip that thing down. But I've tried putting a new battery on the car and it still only goes click. So it's getting to the point where I've got to do a strip. So first of all, I took the bolts out of this end of the motor here, hoping initially that this was the motor when I was looking at it on the car, and I was hoping that this part, that this was the solenoid, a very big chunky solenoid, but I was hoping that this would pull away and then I could clean the barrel up inside the solenoid and so on, and then put it back together. But no, this is the motor. So I've had to go in from the other end now, trying to work out how this thing strips. So what I've done is I've put this thing in the vise. I've loosened those two bolts there, just so that they are, as the term says, loose. And they basically screw through into this casting, which is bolted to the front end, you know, the cog end of the starter motor, which engages into the ring gear on the engine. So what we have here is we've got this part which comes forwards when you supply electricity via this wire here, 12 volts you apply on this wire here from your key switch, and that should make this fly forward by operating an electromagnet in the solenoid. Now when the solenoid has travelled far enough, this gear is engaged, another part inside the solenoid should cause a contact for the we'll call it, no, I won't call it high tension, but high current wires which spin the battery. So this here, this end goes straight to the battery, so that's the supply into the motor. Then on the other side of the motor, just sort of around there, that's the other side of the solenoid switch, which comes out and goes in to here to drive the motor. Obviously the negative side is the casing of the starter motor. So the negative is the casing and the positive goes in through there. So the issues we have is we can get a dirty contact on the copper connections, which are the switch end inside the solenoid, and a lack of the magnetic solenoid shooting forward and pushing this cog forward. So the normal problem, I think, is the lack of this flying forward, and as I say, once that flies forward, you then get the contact being made. So there can be a couple of problems. One, that might fly forward and the contact might not happen, or two, as I think is in the case of mine, it's just not moving at all. It's just going click and nothing's jumping forward, nothing's spinning, nothing. So it's all dead. So what I've had to do, mount it in the vise, take those 2 bolts out down here, then there's 3 bolts in at this end, 1, 2 and 3. Now I've taken those out, they're there on the bench in a load of mucky iron filing, so I'll have to wipe them clean. Now once you get to that point, right, I can then strip this off by looking in, by just pulling on that. So there's where the bolts, 3 bolts secured into, and there's where the other 2 bolts from the far end of the motor came up and screwed into the casing there and there. So you can see there's a bearing in there, which is for this, I can't think of the word now, lay shaft. I think that's called a lay shaft. Right, so there's a lay shaft with a gear on it. There's the gear on the end of the electric motor, the DC motor. So that engages in that. Then you've got that, which engages into this gear here, which is in line with the solenoid. So if I dump that there, what we can then do is you'll find this part will lift out, and there you are. That shows you how this part functions. Now I really need a couple of extra hands here, but you can see down there's a spring, and let's see where I dare put this down. My bench is always pretty messy and full, but there you go, a glove will hold it. So what we have down here is we have this spring. Now that spring indicates to me that that is the return spring on the solenoid piston. So this shaft down here should pull forwards, which it does. Now that part is not, from my way of thinking, that part is not flying forwards inside the solenoid. So when I'm putting current on here, it's just not flying forwards. So I've now got to this point, and I've now realised that coming in from this end has not helped me. But I thought, just for those people who are trying to strip one of these things down, and they may also have some issues that they want to look in at this end. So there you are. That's how you strip that end of the starter motor down. But this isn't the problem end for me. So what I'm going to do most likely is I'm going to put some fresh grease on all of this. High melting point molybdenum disulfide grease, it would seem to be. I'm going to re-grease this and slip it back together. Now I could be tempted to get some maintenance oil, spray oil, WD-40, whatever, and spray it down that hole there. And if nothing else, that might penetrate and lubricate the barrel in there that the solenoid is sliding on, and that might fix it, or at least for a short time it might. So that's going back together, and from here I can't see any way that this gets me access to the other end of the solenoid. So this is going back together, so I'm gonna just get on with that, re-grease it and bolt it all back up. Right, so that's the front end, the gear end of the starter and solenoid all put back together. What's up? That's Bo staring at me through the fence. What's up, Bo? Anyway, yeah, so once that's all back together, this is the other end of the starter motor. So here is the solenoid end. As I say, this is the input from the car battery going in on this side here. Big copper electrode in there, or big copper bolt terminal, so I can take that nut off if I need to. And then this is the output end here, which goes to the starter motor, and this is the switch wire here. So I've just taken 3 short Phillips screws out of there. That's what they look like, and I'm just in the process of trying to tap this cover off and see what it shows me. But what I should probably do at this point is undo at least this terminal off here, so that that cable, the starter motor cable, is out the way. So I'll probably do that first, then we're going to pop the cover off and have a look in. Okay, so what I've done is I've taken this cap off, which happens to have a rubber gasket running around, and you can see that basically this part here has a spring in it, and that's not any form of bearing inside there, that's just the cap with a space in it for the plunger to travel up and down in. Now this wire here is the switch wire. That comes through the side here, connects inside there, and there's a wire soldered. Now that wire will run down to a coil winding, copper wire winding, which is around a tube, and when that is engaged it should pull this plunger downwards like so. Now when this travels downwards, this plunger, that should operate the gear down at this end. You can see that pushes forward and engages into the ring gear on the engine. Now when that engages on the ring gear, up at this end there's a copper disc here, and this copper disc engages with 2 copper plates, between a copper plate that's connected to the live from the battery and the copper plate that's connected to this lug here, which the starter motor connects to. So it's just a big switch with copper contacts. So basically this is the plunger, and I should be to pull this out like so, and you can see on the end there's the spring which I was showing you from the other end, that stays in, and here is the iron piston, basically it's a steel, iron, whatever, and this should travel down, and then this copper washer or ring, that is what makes the contact for the starter motor to spin over. So basically what I need to do is I need to put a little bit of lubrication, clean up with a little bit of wire wool this piece of steel here, put a little bit of light machine oil on it, and I need to clean up this copper disc and the copper contacts in there, and put some sort of contact chemical which will help the conductivity and it not to go dirty as fast. So basically it's basically a clean up of all the contact faces and a bit of lubrication, and hopefully when I put it all back together it should work. Right, while I've been cleaning this up, I've noticed that the contact on this side, the positive feed from the battery, is quite worn. There's a step in it down there. Now, you can buy a servicing kit for this starter motor on eBay and probably on a number of other sites for around £13 including the postage. So I'm very tempted to order one of those rather than just cleaning this up and putting it back together. The kit also comes with this piston and presumably the copper connector and all the spring and so on. So I think I'm going to go and have a look at that and maybe order that. But I might just try these parts back in and see. It could be that there's no issue there at all, and that cleaning this up will get another. Well, this has probably never been taken off for 30 years, so there's a good chance I might get another 30 years out of it just by cleaning it up. Now, before I clean that up, you can see I pushed a bit of paper toweling down inside there so that I didn't get bits of dirt going down and into the gears at the bottom. So hopefully I can pull that out and dispose of that carefully with all the other crap on the desk. Yeah, so there we go. Now, I did try cleaning this out down inside here. I think it's probably alright. I suspect it's probably brass, the tube. It'll be a brass tube and then this steel piston runs up and down in it. So there's the spring. I might, yeah, it seems to be alright. It's just grease on the end of it. So I think I should be able to drop that back down inside there. Better still, put the spring over that, then place that inside and hopefully it'll all go back together. Now when I do this for good, I'll put a bit of lubrication in there of some form. Come on, in you go. There we go, there we go, there we go. Yeah, so that's what should happen. Now that should fly forwards and it should contact with that brass contact point down there. Now it could be due to the wear on that contact that it's not going to do it very well. Now you could mess around with this. You could possibly take it off and try and fashion a new component for it out of a bit of scrap copper, or you could try and solder another piece of copper over the top of that one. But what will happen though is if you try putting solder anywhere near that, the contact will supply so much current through it that it will get hot, and the copper and lead, the lead solder will just drop off. It would, due to the heat, it'll just melt, fall off, and it'll cause short circuits inside the motor. And trust me, you don't want short circuits inside the contactor on the starter motor, because this thing is connected straight to your battery. There generally isn't any fuse, so you start getting short circuits in there, you're up for big problems. Insulation burning off on your battery, fires, maybe even your battery bursting, exploding almost. So you just don't want to mess around with getting bits of junk inside here. Yeah, so while I was messing around in here, I also noticed that there's a wire coming off there which goes from that winding over to the other contact over there. I'll have to think about that a little bit, because I thought that would just go to the negative case. You see there's a copper wire inside there at the end of my finger. Presumably that's the other end of this winding supplied from here. So slightly puzzled. As far as I know, that's definitely the live, but then again I could be wrong. This might, in fact, looking at the colour of it, it's black. So does that make sense? Does that make sense? No, it doesn't make sense, because this is the output going to the motor. Have a think, have a think. Well, it could be picking up negative through the winding of the motor, coming back through that terminal. So would that make sense? It possibly does. Anyway, there's a wire there and there's the wire here. Yeah, I'll have to think about that a little bit more. Right, okay, so yeah, so I think I'll go online and check out this contact kit and piston kit. Okay. Okay, so while I've been waiting for the repair parts to turn up, I decided I would clean all the rust off the starter motor body and repaint the various parts which were starting to corrode. So I've painted them in a rust protective paint, which looks suitable. Now the repair kit has arrived, and sure enough it consists of the new, well, I'll call it plunger for want of a better word. Don't know what else they call it. Yeah, it says here remove plunger, so that's what I've done already. Right, so there's the new plunger, all nice and shiny. Personally, I don't really think I needed a new one. I don't think there was really very much wrong with the old one, but I will put the new one in, seeing I've got it. But I might hold on to that. Don't know what I'll do with it. Stuff it in a bits box somewhere. Right, so the new copper contacts which have come with this are, as you can see, larger than the old ones. Now I'm hoping these are going to fit, and I'm only going to know once I take the nuts off here and start to stripping out. It says in the little instruction booklet to do them one at a time. Well, so that you don't mix them up. One at a time is best, so don't mix up the contacts. But as the contacts look completely identical to each other, I don't see what the fear is here. Not getting that. You can see these instructions probably cover a few different types of sets. See, there's different styles of plunger and different styles of contact. Now those small contacts are more like mine, but I don't see any reason why these large ones won't fit, and a larger contact face should in theory mean that they will last longer than a small contact face. The larger surface area between the various switching components means that they should last better. Less current shared over a bigger area. Okay, but in theory there's always going to be one point which is slightly raised higher than another point. Yeah, okay, not going to go into this too deep. Basically, it's a simple job. I'm going to strip these nuts off, take the contacts out, put the new ones in, throw the piston back in, maybe with a little bit of light machine oil or a bit of grease of some form, maybe copper slip grease, because copper slip grease is shouldn't have any magnetic effect, and it should hang in there okay even if it gets a bit warm. So I might use copper slip. That sounds like a fair idea, as long as the copper slip doesn't migrate back here and then become a contact issue. So thinking about that now, it might not be a wise idea to put copper slip grease in, and I might just go for a light coating of molybdenum. Yeah, that's probably more of a sensible idea. Right, I'm going to get on with that anyway, so give you an update in a minute. Okay, so that assembled up quite easily. The old contacts, you can see, were halfway worn through, so it was worth changing them out. The new ones do look quite nice. At least one side, as I say, one side was halfway worn through. I think it was the side which was coming in from the live feed from the battery over on this side here. Now make sure that you get these rubber covers back on properly. This one on this side with the battery terminal was a bit of a pig to squeeze back on, but it is worth it because you're going to potentially stop any accidents if a stray bit of metal went down here and basically caused a short between this and the case. You could have some issues, so it's well worth taking the time to make sure this cover goes on correctly. Now I've also sprayed a little bit of copper slip spray grease, copper anti-seize, yeah, on the contact surface on the nut head there, and once again make sure that these covers go on well. The side to the motor, it's still important to make sure that the cover goes on well, but probably not quite as important as this one, because this one is always live. As long as the battery is connected on the vehicle, this connection is a live point. Right, so all ready to get it back on the vehicle then. Okay, so that's the starter motor all bolted back up. Yeah, so I had to touch up the battery, the paintwork a little bit after I put it back because it scraped off while I was squeezing it in there. I've tightened up the bolts at the back end there, all looking pretty good. I think the one thing I've got to still do is put this cable here back, tied back to this flexi fastening point on the back of the motor. So I might just use a cable tie on that to secure it down rather than trying to wrap it. But I'll do that a bit later. Yeah, so I suppose time is to start it up. Yeah. Yeah, okay, people are watching this because it's a Daihatsu starter motor. Well, it is a Daihatsu starter motor, but it's in a lightweight Land Rover. So what's the problem? These things happen. Lightweight Land Rover, Daihatsu starter motor, and a 1954 American-made Jeep wheels. So there you go, strange concoctions. So, yeah. As they say, here goes nothing. Do. Let's hope Basically it has a series of pulses which are to start up the glow plugs. Why have I got my indicators going? Don't need that. So there's the pulses going through from the glow plugs. I'm not sure how many it does, I've never counted them. The charge light is there on the little Land Rover display. Then here I've got Daihatsu speedo and rev counter, and that's the last pulse. So there we go. Started. So it's fixed. This is a little speedo which you can get on eBay for about £20, and having one of these saves you having to look down and look at the speedo which is down there. So when you're driving it's a little bit more convenient. So you could place this anywhere you wanted. I could stick it over in this area here, or try and work it in behind the steering wheel. Yeah, I've done a few little mods on this. I've got well, it's a custom dash. Then I've got USB charging points here, and I'm running this off a USB socket. Yeah, so pretty much okay. I've done lots of little repair jobs on this vehicle in the last, say, 18 months. I had to change the fan down there because by default lightweight Land Rovers have a 24 volt motor, and you've got to change it to a 12 if you're running it on 12 volt electrics. That's a bit of steam because there's a bit of damp on the exhaust piping. Yeah, so no fire, all going okay. Got electric fans on this which are fitted because the space was too bulbous to have the original engine ran fan on it. So there you go, sorted. I've made my own stainless steel exhaust for this. Comes out the side, and it's got a plastic boat fuel tank just up here. New aluminium under there, chassis all repainted. Nice little high flow air filter. Anyway, that's the end of it. Hope you enjoyed that.